Hello viewer, today we will be solving the IB Math AHL November 2024 paper 3 question number 2. You will be getting the solution for the first question of the same paper and the solutions for the other questions from the other past papers in form of playlist on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I'm Nilanjana Sanyal. I'm an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start to solve this question number 2. The maximum mark is 28. Polynomial is said to be palindromic if the sequence of its coefficients remains the same in reverse. This question asks you to investigate some properties and solutions of palindromic polynomial equations. In parts A and B, consider quadratic equations of the form ax squared plus bx plus a equal to 0. See, the coefficients are a, b, and a, and if you reverse the coefficients, it will still be the same. This will be coming to this point, and this will be going over here. This constant term a will become the coefficient of x squared, and this coefficient of x squared will become the constant term. But because both of them are a, so practically the polynomial stays as before, okay? And a is not equal to 0. The sequence of coefficients a, b, a remain the same in reverse. The following table shows 3 palindromic quadratic equations and their sequence of coefficients. 2x squared minus 5x plus 2 equal to 0. The sequence is 2 minus 5 and 2. And x squared plus 4x plus 1 sequence is 1, 4, 1 and x squared plus 1 equal to 0. Sequence is 1, 0, 1 because this is x squared plus 0x plus 1 equal to 0. Okay? So, the quadratic equation 2x squared minus 5x plus 2 equal to 0 has roots 2 and half. These roots form a reciprocal pair since one root is the reciprocal of the other. Support A is having 2 for the support I is saying determine the roots of x squared plus 4x plus 1 equal to 0. If these roots in the form of s plus minus root t, where s is an integer and t is a positive integer. Okay, so a and I, x squared plus 4x plus 1 equal to 0. It cannot be factorized, so I have to use the quadratic formula. So x equal to minus b, b is 4, so minus 4 plus minus square root of b square, so 4 square is 16, minus 4ac, so minus 4 times, this is 1, times 1 times 1 over 2a, 2 times 1. Okay, so therefore x equal to minus 4 plus minus 16 minus 4 is 12 over 2, and we have to get rid of the denominator. So first of all, let me simplify this one. So minus 4 plus minus and square root of 12. Always you have to get the prime factors of the number within the root. So it is 2 times 6 and 2 times 3. And since it is the square root, we have to pair the numbers and we have to take out one number from each pair. So there is only a single pair for 2, and we will be taking 1, 2 outside the radical sign because there is a single pair. So it is 2, and this 3 is an isolated one, so it will be staying within the root. This is this 2 root 3, square root of 12 is equal to 2 times square root of 3 over 2. And this is equal to minus 4s plus minus, so I do not have to write them separately. Sorry, I have to divide by 2. So 4 divided by 2 is 2, and this 2 divided by 2 will be 1. So minus 2 plus minus root 3. Okay. E is 3, a positive integer, and s is negative 2, an integer. Okay. Hence or otherwise support II, hence or otherwise show that these roots form a reciprocal pair. Okay, so if the two roots form a reciprocal pair, then the product of these two roots will be equal to 1. Like 2 and half, if you just multiply them, the product will be equal to 1. Okay, so let us multiply these two roots and let us see what product do we get. So minus 2 plus root 3 and minus 2 minus root 3. So this is equal to minus 2 times minus 2 is 4. Minus 2 times minus root 3 is plus 2 root 3. Root 3 times minus 2 is minus 2 root 3. And root 3 times minus root 3 is minus 3. So these two will be getting cancelled and 4 minus 3 is equal to 1. Therefore, minus 2 plus root 3 is equal to 1 over minus 2 and minus root 3, or minus 2 minus root 3 is equal to 1 over minus 2 plus root 3. Okay, so therefore the roots form a reciprocal pair. Okay, the part B, show that the complex roots of x square plus 1 equal to 0 form a reciprocal pair. Okay, so let me come over here. Complex roots. For this also we have to use the quadratic formula. So this is x equal to, this can be written as x square plus 0x plus 1 equal to 0. So x is equal to minus b, so minus 0 plus minus square root of b square, so 0 square, minus this is 1, so e is 1, c is 1. So minus 4 times ec, e is 1 and c is 1 over 2e, so 2 times 1. So therefore, x is equal to plus minus, this is square root of minus 4 over 2. This can be written as plus minus square root of 4 times square root of negative 1 over 2. Okay, so therefore x is equal to, square root of 4 is 2. So x equal to plus minus and square root of negative 1 is I. So plus minus 2i over 2, or x equal to plus minus I. Okay, and now we have to show that they form a reciprocal pair. So I am taking I times negative I equal to negative I square, and I square is equal to negative 1. So negative of negative 1 is equal to positive 1. So therefore I and negative I form a reciprocal pair. Okay, let p of x equal to x square plus bx plus a, where a is not equal to 0. So part C's question is, verify that p of x equal to x square times p of 1 over x, where x is not equal to 0. Okay, so p of x, let me just write the polynomial expression, ex square and plus bx plus e, and verify that p of x equal to. Okay, so since p of x is this, so what will be p of 1 over x? We will be substituting 1 over x wherever we are having x in the expression. So p of 1 over x will be equal to a times 1 over x whole square plus b times 1 over x plus a. Okay, so therefore p of 1 over x equal to a times 1 over x square plus b times 1 over x plus e. Okay, and we have to show that p of x equal to x squared times p of x equal to x squared times p of 1 over x. So, and of course x is not equal to 0 because otherwise we cannot have 1 over x. So x squared times p of 1 over x. So therefore x squared times p of 1 over x is equal to x squared times a times 1 over x squared plus b times 1 over x plus a. Okay? Equal to, these two will be getting cancelled, so we will be having a plus for this x and x squared, so it will be bx plus ax squared. Okay, which can be rewritten as ax squared plus bx plus a, which is equal to p of x. Okay, so we have verified this. Okay, parts D and E, you may assume that the result that a polynomial p of x of degree n is palindromic if and only if p of x equal to x to the power of n times p of 1 over x. The part D's question is use p of x equal to x to the power of n times p of 1 over x to show that if a is not equal to 0, that if a which is not equal to 0 is a root of p of x equal to 0, then 1 over, it is not a actually alpha, then 1 over alpha is also a root. Okay, so since alpha is a root of p of x, therefore p of alpha will be equal to 0. Okay, and I'm just substituting alpha in place of this x. Okay? Using p of x equal to x to the power of n times p of 1 over x. P of alpha will be equal to, in place of x, I am writing alpha. Alpha to the power of n and p of 1 over alpha. Okay, and p of alpha is equal to 0. So therefore 0 equal to alpha to the power of n and times p of 1 over alpha. Alpha to the power of n is not equal to 0 because alpha is not equal to 0. Okay, therefore p of 1 over alpha is equal to 0 because the product is equal to 0. Therefore 1 over alpha is also a root. Okay, done. Let f of x equal to p of x times q of x, where p and q are palindromic polynomials of degree n and m respectively. The part A's question is show that f is a palindromic polynomial. Now, this is the first time that I am seeing this. May appear to be a little challenging for some students, but this question number 2, all the other suppers were very straightforward. This one, okay, it is not very challenging, but you may get confused. No problem, but they are saying that p and q are palindromic polynomials of degree n and m respectively. So p of x will be equal to x to the power of, because p is having the degree n, So this will be equal to x to the power of n and p of 1 over x. Okay. Similarly, q of x is equal to x to the power of m and q over 1 over x, because p of x and q of x are palindromic polynomials. Okay. Of degree n and m respectively, I'm not writing the whole thing. F of x is equal to p of x times q of x. And in place of p of x, I'll be writing this expression, and in place of q of x, I'll be writing this expression. So f of x equal to x to the power of n, p of 1 over x times x to the power of n, q of 1 over x. So this is f of x is equal to x to the power of n times x to the power of m is equal to x to the power of n plus m or m plus n, and p of x, p of 1 over x times q of 1 over x. Since f of x equal to p of x times q of x, so f of 1 over x will be equal to p of 1 over x times q of 1 over x. Okay. Therefore, f of x is equal to x to the power of n plus m. You can change it to m plus n. So, and f of 1 over x. Okay. So the question is, so that f is a palindromic polynomial. So therefore, f of x is a palindromic polynomial of degree m plus n, or degree n plus n, whatever you want, you may. Okay. Okay. Shown. Consider the palindromic polynomial f of x equal to x to the power of 4 plus 2x cubed minus x squared plus 2x plus 1. This polynomial can be expressed in the form f of x equal to x squared plus ux plus 1 and times x squared plus vx plus 1, where u and v are integers and u is less than v. So, but if is saying by forming and solving an appropriate system of equations in u and v, determine the value of u and the value of v, and it is containing 6 marks. Okay, so first of all, let me write the expression for f of x. It is, okay, let me write this. This one is f equal to f of x equal to x to the power of 4 plus 2x cubed minus x square plus 2x plus 1. Okay, I just copy it. So now you can see properly. F of x equal to, and so now I'll be writing this. So this is equal to x square plus ux plus 1 and x square plus vx plus 1. U is less than v. U and v are integers. So let us just equate the coefficients of different terms of x from both the sides. So if you expand this, what happens? The right hand side is equal to x to the power of 4, and then I will be having a term containing x cube. How can I get x cube? When x square is multiplied with this vx, I'll be getting one term containing x cube. And when ux is multiplied with x square, I'll be getting another term containing x cube. So it is v times x cube and u times x cube. So u plus v x cube plus, now it is x square. So how can I get x square? X square is x square times 1 will be giving you 1 x square times 1. This one will be giving you another x square. So let me just write, this is x square. So it is 1 plus 1. And when ux is multiplied with vx, you get uvx square. So uv. This is x square. Now coming to the x. How can we get x? When ux is multiplied with 1, you get x, a term containing x. When vx is multiplied with 1, you get one term containing x. Okay. And you cannot get any term containing x from multiplying other terms. And finally, the constant term will be obtained by multiplying this one with this one. So it is 1. So you see, this is x4, x to the power of 4. This is x to the power of 4. The constant term is 1 in both the cases. And this is u plus vx cube. So this is 2x cube. And this is u plus vx. So this is again 2x. So u plus v is equal to 2. Okay. Therefore, u plus v is equal to 2. And this is 1 plus 1 is 2 plus uv. This will be equal to minus 1. So 2 plus uv is equal to minus 1. We are having two equations, two unknowns, so we should be able to solve these. So I can write this as, say, u is equal to 2 minus v. Okay. So from here, it is 2 and plus 2 minus v times v is equal to negative 1. So 2 plus 2v minus v square equal to negative 1, or I can write this as v square and minus 2v and minus 3 equal to 0. Okay. So, and I can factorize this. This will be v square and plus v minus 3v minus 3 is equal to 0. So v square, or else I can take v as the common term from the first two terms. So it is v plus 1 and minus 3 as the common term from the next two terms. It is v plus 1 equal to 0. And this will be giving us v minus 3 times v plus 1 is equal to 0. Okay. So therefore, v is equal to 3 or v is equal to negative 1. When v is equal to 3, what is u? We have to get both the values. So u is equal to 2 minus 3 equal to negative 1. And for this, it is u equal to 2 minus minus 1, which is 3. Okay. But they have said u is less than, smaller than v. So we cannot take, because u is lesser than v. So therefore, we have to take these values. So therefore, u equal to negative 1 and v equal to 3. Part G, hence, so we have to use the information that we have collected from the previous subparts, find all the exact complex and purely real roots of x to the power of 4 plus 2x cube minus x square plus 2x plus 1 equal to 0. This is the expression for f of x. Okay. So, okay, and we have factorized this whole thing into two quadratic factors. So, and we can solve the quadratic factors. So we will be getting the four roots. First of all, let me write the f of x expression. Okay, so it is t f of x equal to x to the power of 4 plus 2x cube. I'm reading the topmost line. Minus x square plus 2x plus 1 is equal to 0, and therefore f of x equal to, it will be x square plus u. X u is negative 1, so it is negative x plus 1, and x square plus vx, v is 3, so plus 3x plus 1 is equal to 0. Okay, and we cannot factorize any of them, so we have to use the quadratic formula. So x square minus x plus 1 equal to 0. A is 1, B is negative 1, and C is 1. So x equal to negative B, so it is positive 1 plus minus square root of negative 1 whole square, B square, minus 4AC, so 4 times 1 times 1, over 2A, 2 times 1. This should be equal to 1 plus minus square root of minus 1 whole square is plus 1, so 1 minus 4 over 2, and this is 1 plus minus square root of negative 3 over 2. So this is 1 plus minus square root of 3. You do not have to write so many steps. I am writing them just to show, explain in detail. Okay. So this is this, and root negative 1 is I, so it will be 1 plus minus root 3I over 2. So I can separate the real and the imaginary parts. So these are the two complex roots, and for the real roots, I have to solve this part, x square plus 3x plus 1 equal to 0. So therefore, again, E is 1, B is 3, and C is 1. So minus B plus minus square root of B square, which is 9, minus 4 times 1 times 1, 4AC, over 2 times 1, equal to minus 3 plus minus square root of 9 minus 4, which is 5, over 2. So this is minus 3 plus root 5 over 2, and minus 3 minus root 5 over 2. Okay, so therefore the four roots are half plus root 3 over 2I, half minus root 3 over 2I, and minus 3 plus root 5 over 2, and minus 3 minus root 5 over 2. Okay. Now we come to the last part of this question. Consider the palindromic polynomial equation x to the power of n plus a1 times x to the power of n minus 1 plus a2 times x to the power of n minus 2 plus a2 plus dot 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 plus a2 x square plus a1 x plus 1 equal to 0, where n is odd. The part H is saying show that minus 1 is always a root of this equation. Okay. Okay, so this is the part H. I have brought this question down. N is an odd number. Okay, so there are n plus 1 time number of terms, because this is the constant term which is having the power of x as 0. So it is from 0 to n. The powers of x are ranging between 0 and n, both included. So there are n plus 1 number of terms. Therefore, n is odd. So maybe n is, if suppose n is 9. So n plus 1 number of terms means 9 plus 1, which is 10, which is an even number. 1 plus an odd number is always an even number. So it will be divisible by 2. So you can divide this by 2 and you will be having two parts. One will be having 5 terms, another will be having 5 terms. Okay. So since there are n plus 1 number of terms, n plus 1 is an even number. So you will be having n plus 1 over 2 terms in the first half, first set, and n plus 1 over 2 number of terms in the second set. Okay. You will be having equal number of terms in the two sets if you divide the terms. Okay. The left set will be having n plus 1 over 2 number of terms, and the right set will also be having n plus 1 over 2 number of terms. Okay. And it is a palindromic polynomial equation. Okay. So now let us see what happens when x is equal to negative 1. Negative 1 raised to the power of n. N is an odd number, so negative 1 raised to some odd number will be negative 1 plus a1 times negative 1 raised to the power of n minus 1. So n minus 1 is an even number plus a2 times negative 1 raised to the power of n minus 2 and plus dot 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 plus a2 negative 1 square plus a1, because it is a palindromic polynomial equation. So a1, a2, these are also getting these are also appearing in the reverse order. And minus 1 and plus 1. Let us see whether this is equal to 0 or not. Okay. So since n is odd, therefore n minus 1 will be even, n minus 2 will be odd, and these parts, they don't have to do anything. Okay. Therefore, maybe this is the expression A. Therefore, A is minus 1 to an odd number is minus 1 plus n minus 1 is even. So minus 1 raised to the power of an even number is 1. So it is plus a1. N minus 2 is odd. So minus 1, it will be minus 1. Minus 1 raised to some odd power is minus 1. So it will be minus a2 and plus dot 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 plus a2 minus 1 whole square is plus 1 plus, sorry, not plus, minus and plus 1. These two will be cancelling, these two will be cancelling, these two will be cancelling. So, and you know there are even number of terms, and you will be having two exactly not similar, but you will be having two sets containing the same number of terms, and the coefficients, since it is a palindromic polynomial equation, the coefficients will be appearing in the reverse order. So this should be equal to 0. Okay. Since I can write, since n is odd, n plus 1, the number of terms, it is containing 4 marks, so let me write this. Number of terms on the left side of the equation is even. Therefore, it can be divided into the left half and the right half with n plus 1 over 2 number of terms present in each half. Okay, because the given equation is a palindromic polynomial equation, the coefficients of the left half terms will appear in the right half term in reverse order and will ultimately get cancelled. Okay. So we have shown. Therefore, negative 1, or since the expression becomes equal to 0, therefore, negative 1 is always a root whenever n is an odd number. Okay. So we have completed solving this question number 2. Thank you for staying with me till the end and watching my video, my explanation. Please like and share this video in case you have liked my explanation, and please do not forget to subscribe to my YouTube channel. It will not be taking you many minutes, but it will be really helping me a lot. We meet again very soon in our next session. We start to solve a new paper. Till then, bye.